This is lesson 4.3, functions. The idea behind this is to go at your own pace. If you need to rewind, play something back, pause, whatever the case may be, then go ahead and do that and kind of learn at your own pace here and proceed accordingly. So first of all, please take a couple of minutes as you usually do and do the quick check independently. And when you are ready for checking answers, unpause and continue. Okay, let's continue, shall we? So here's what we have. At a water park, you can rent a raft for $2 per hour. Make a table of ordered pairs in which the x-coordinate represents the number of hours and the y-coordinate represents the total cost for 1, 2, or 3 hours. So first of all, it's saying without saying that you need to have some sort of a linear equation. So based on the information here that it's $2 per hour, I think we're going with the equation y equals 2x. That way when you make your table, and you've got your x and your y values. We're given 1, 2, 3, and 4. We should be multiplying each of those x values by 2, which would give me 2, 4, 6, 8. Graph the ordered pairs. Okay, these are all positive numbers, which means all I need is the first quadrant. I need 1, 2, 3, 4 going this way, so 1, 2, 3, 4. Sorry about the penmanship. This is not the easiest program to use. Here's the 0. And then we're going to go up 2, 4, 6, 8. And again, if you wanted to, actually for this one it's not really necessary to do that jagged line showing the space between 0 and the first value that you're using. That's really not necessary here. You can just do 0, 2, 4, 6, 8. Now, what do these mean, of course? We're talking hours down here. And we're talking cost in dollars along the y-axis. And then we're just going to plot these points. 1, 2, 2, 4, 3, 6, 4, 8. Should look like a straight line. Nothing complicated. State the domain and the range of the relation. Okay, so again, the domain is the set of the x values. So we should have these in numerical order from least to greatest. -4, -1, 2, 3. Those are the x values. The range is the y values. There is a repeat. If you notice that 6 is there twice. So you only need to write it once, but again, it's best if you put them in order from least to greatest. So -5, 0, and then 6. That's for number 2. Number 3, what is the range of this relation? So again, the range is the y values. It looks like we've got 1, 2, 3, which would be C. There is a repeat, but we only have to write it once. So our I can statement for the day is that I can find the value of a function for a certain number, and I can make a function table of values. We're going to be doing both of those things. And you'll see that the first 2 lessons especially kind of lead into this, and then we can kind of see how these apply to different areas of mathematics. First of all, let's take a look at some definitions. First, what exactly is a function? A function is a relation, so remember what a relation is. It's an ordered pair, in which every x has a y. So this is an example. It's a linear relationship or a linear function. What it means when it says every x has a y means that when I input an x, I'm going to get a y, and I'm going to get a different y each time. So, for example, a function table tells you the input, the output, and the rule. You've seen these before. That's what that looks like. It's a function table right here. Gives you a rule in the middle with the x on one side and the y on the other side. You input the x into the rule and it spits out the y value. So the x is the input and the y is the output. Independent variable versus dependent variable. We talked about these as well. The independent variable can stand alone. It can be any number. You can choose whichever x values you want to put into this equation. So in the equation y equals 2x, x is the independent variable. The dependent variable is the value that is affected by the independent variable. So in this case, it's the y. Depending on what x is, it's going to change y. When x is 0, y is 0. When x is 1, y is 2. When x is 2, y is 4. So y depends on x. Therefore, y is the dependent variable. So let's take a look at some examples. First of all, understand this concept here. Whenever you see, this is called f of x, by the way, f of x. So this is a function notation right here. F of x is basically the same thing as the y coordinate. Why do they call it that way? Because this is the output value. This is the range that is a function of the input, okay, which is going to be the x value. So if I consider that notation, find f of negative 3 if f of x equals 2x plus 1. We had a Kahoot that showed you these different things, and it was somewhat of a struggle for some of us, I guess, but the long story short is, whatever is in the parentheses numerically, I'm going to substitute in wherever I see an x. So here's generally how we do this. It's a three-step process. Step one, we simply write the function. So I'm going to copy it down exactly the way that it appears. It's going to look like this. F of x equals 2x plus 1. Step two is that I'm going to substitute. And in this case, I have an input value, right? Substitute the x value. So in this, instead of the x being there, and this is just kind of a technical thing, so I'm going to plug negative 3 in there, and I'm also going to plug negative 3 in there. So this is called f of negative 3, the function of negative 3, and then I'm going to calculate what that is. So this is just simply simplify. Simplify. So again, I'm going to calculate 2 times negative 3 should give you negative 6. And negative 6 plus 1 gives you negative 5. So f of negative 3 is negative 5. Done. Rewind that, play it back if you have to. It's pretty cut and dry. And then if you would not mind doing this next example on your own, check back when you are ready. So here's what it looks like. Copy down the function, f of x equals 3x plus 4. Substitute negative 6 wherever you see an x, so it goes in for the x on that side, it goes in for the x over here, and then simplify. 3 times negative 6 is negative 18, negative 18 plus 4 is negative 14. So that means that f of negative x equals negative 14. Okay? So understand this, you could simplify this or write this as an ordered pair if you were required to do that. You're not yet, but just so that you have an understanding of what we're looking at, we're considering that, whoops, excuse me, that should be negative. Negative 6 is the x and negative 14 is the y. So this is the input, this is the output, so you could represent that as that ordered pair. It's just something to keep in mind as you're moving along. Let's take a look at example 2. Alright, so it says choose 4 values for x to make a function table for f of x equals x plus 5, then state the domain and the range of the function. So the first thing that we're going to do is make a table, and we're going to fill in the input values with any 4 values that we want. And I'll show you kind of what makes sense to pick in terms of what's going to give me the best idea for looking at a function. So first of all, let's make our table, and we can go from there. This is what my table would look like. So I have my x, which is my input, my rule, which is f of x equals x plus 5, and then my f of x, which remember stands for my y value. So this is the output. Input x, and then out comes f of x. There's my rule in the middle. I recommend, unless you are specifically told which x values to choose, negative 1, 0, 1, and 2, especially because it says 4 values. If it only said 3 values, then I would pick negative 1, 0, and 1. Why? Because it gives you a pretty good snapshot of what that function is going to look like, and then if I was ever asked to graph it, it would give me, again, a pretty good snapshot of what the graph looks like. So anytime it says pick your own values, obviously you can pick your own. However, again, I strongly recommend picking the same values every time so that you get an idea of what it's going to look like. So I'm simply going to substitute each of these values in for every time I see an X, and you're going to then calculate the output value based on each of those. So let's go ahead and do that. So again, substituting in the values is going to look like this. Now I have f of -1 is -1 plus 5, f of 0 is 0 plus 5, f of 1 is 1 plus 5, and f of 2 is 2 plus 5. So these are the input values, and then I'm going to calculate my output values by calculating whatever this addition is. So f of x for f of -1 is going to be positive 4, and 0 plus 5 is 5, 1 plus 5 is 6, 2 plus 5 is 7. So each of my output values that corresponds, I don't know what's going on here, each of my output values is going to, sorry, you get the idea. Thanks for bearing with me. I don't understand. There we go. Now we're in good shape, I think. Oops, wrong one. There we go. So again, -1 plus 5 is 4, 0 plus 5 is 5, 1 plus 5 is 6, and 2 plus 5 is 7. So now I have an input and an output value for each of those. Then state the domain and the range of the function. Okay, well you have the domain right there. It's already in order for you, so we're just going to state that. And then the range, in this case, happens to be in numerical order as well. It won't always be that way, but we can declare each of those like so. So here you go, step 3, state the domain and range. The domain is -1, 0, 1, 2. The range is 4, 5, 6, 7. Domain is the x values. Range in this case is the output values or the y values, f of x values. So we're done with that one. Using these steps and this information, please do this next one on your own. Pause the video now and resume when you are ready to check. Okay, so your table looks like the following. If you choose the 4 values that were recommended, -1, 0, 1, and 2 for your input values, your rule here is the f of x equals 4x minus 1, so that just came directly from the problem. And the f of x is the output. That's what that looks like. So I put in these values. I calculate 4 times -1 is -4, minus 1 is -5. 4 times 0 is 0, minus 1 is -1. 4 times 1 is 4, minus 1 is 3. And 4 times 2 is 8, minus 1 is 7. So my output values are -5, -1, 3, and 7. I can state those in set notation. The domain is -1, 0, 1, 2. That comes from right there. And the range is -5, -1, 3, and 7. And that comes from right there. So there's your domain and your range. That takes care of those first 2 examples. You are going to now need to go on to the second video for the rest of the lesson. Review anything you need here first on examples 1 or 2 before you move on.